Hello, wonderful algebra students, and welcome back to another lesson summary video. This video is going to be a summary of what we learned in lesson 4 of Unit 1. The lesson was called Equations and Their Solutions. And there was two major goals for this lesson in particular. The first was reviewing how we find solutions to equations, and then the second is interpreting what it means to be a solution to an equation. I think this lesson really builds on the work we did back in pre-algebra with solving equations and identifying what the solutions are to those equations. One of the first things we introduced in this lesson is the phrase equations in one variable, and I think the definition to that is what it sounds like. It's going to be an equation with one variable, or an equation that has only one unknown quantity, aka one variable in it. To help us review equations in one variable, we're going to use this example here about Juana. I'm going to scroll down a little bit. We're told that Juana has time on the weekends to earn some money. A local bookstore is looking for someone to help sort books and will pay $12.20 an hour. To get to and from the bookstore on a workday, however, Juana would have to spend $7.15 on bus fare. We're asked two questions. The first question asks, one day, Juana takes home $90.45 after working 8 hours and after paying the bus fare. Write an equation to represent the situation. And then the second problem is asking us to solve that equation we wrote in number 1 and identify the solution and what that solution means in this situation. I'm going to ask you to go ahead, pause the video now, and see if you can work out number 1 and number 2 on your own. This does really build on the work we did back in pre-algebra, so hopefully questions like this look a little familiar to you once you've tried number 1 and 2, and then come back and see how you did. All right. So for number 1, it's asking me to write an equation to represent the situation. The important information in the story that's going to help me figure out what that equation looks like is I need that hourly rate she's going to make. She's going to make $12.20 each hour she works. They also tell us in that one day to get to the bookstore and to get back home, she's going to have to spend $7.15. And that's just like a one-time cost to get to and from the bookstore. So she's only paying that once. Using that information and the fact that she takes home $90.45, I can come up with the equation of 12.20h. That's coming from the fact that she makes $12.20 every hour. And then she's spending $7.15 on the bus fare. That means that's money she's going to have to take out of what she makes from the bookstore. So with that $7.15, we're going to need subtraction there. That $12.20 each is that money she's making from that hourly salary, and then I have to take out the $7.15 for the bus. That $7.15 doesn't need a variable because she's not multiplying it. It's just a one-time thing she has to pay in that day. And then we know that day she made a total of $90.45 after working those 8 hours and after paying that bus fare. So we get this equation here. If you didn't have this equation, that's okay. Hopefully it makes sense now. But if you didn't have this equation, go ahead, pause the video and see if you can try number 2 now that we've got an equation we're working with. For number 2, if I want to identify what the solution is for this equation, it means I just need to solve this equation we've got. Using those inverse operations to help us solve these equations, I'm going to start with that constant. That's that $7.15, and I'm going to do the opposite, which would be adding the $7.15 to both sides of our equation. When I do that, I'm left with that 1220h. Those 715s cancel out because it would equal 0. So I get 1220h equals, and then on our other side, it's going to be $97.60. This right here is telling me that she made $97.60 before she paid for the bus. So that must have been what the bookstore paid her. And then once you take out that $7.15 for the bus, that's what left her with that $90.45. Our last step, because we want to get h all by itself, is I'm going to divide both sides by that 1220. And when I do that, I get h equals 8. That would be the solution for our equation. Now, there's two parts to this question. The first part is, what is the solution? And we figured out the solution is h equals 8. The other part is, and what does the solution mean in this situation? When we say h equals 8, what does that mean? Well, it means a couple things. First off, if I were to put h equals 8 into words, that solution is telling me, if h is the number of hours she's working, it's telling me she worked 8 hours. The reason why we know she works 8 hours is because that number meets all the constraints of this problem. And I just used one of our old vocab words there. Constraint, remember, are the limitations. Some of the constraints in this problem is that she's only making $12.20 an hour, and she has to spend the $7.15 on the bus, and the fact that we know she took home $90.45. 8 hours is the only possible solution that's going to make all three of those things true. And we can see that if we substitute that number back into our equation. If I substitute 8 into this equation, I'm going to see that that number 8 satisfies our equation. 1220 times 8 is $97.60. And when we subtract 715, it does in fact give us $90.45. And sometimes you'll see $90.45 equals $90.45 just to show that's true. If you were to pick any other number in the world other than 8 and try putting that into the equation, you wouldn't get a true statement. You would get some other number that's not $90.45 on one side and $90.45 on the other side. So to summarize what we're seeing here, this equation we had started off with is an example of an equation in one variable. I know it's an equation in one variable because there's only one variable. H is that only quantity that we don't know in that situation. The solution to this equation is the only value h could be to meet the constraints. The constraints being all the stuff they told us about money. And there's only one possibility. That one possibility is that solution we figured out. It's that she must work 8 hours. The last part of this is if you picked any other number for h, it wouldn't result in a true statement. For example, if I picked the number 1, that's not going to give me $90.45. 1220 times 1 is 1220. And 1220 minus $7.15 would be $5.05. And that definitely doesn't equal $90.45. So that's what we mean by it wouldn't result in a true statement. This was one major topic we had talked about in this lesson. The other topic was something we called equations in two variables. And you could probably guess what an equation in two variables is. It's going to be an equation that has two unknowns or two variables in it. To help us talk through solutions for equations in two variables, we're going to use this example right here about Tyler. So we've got, suppose Tyler spends $45 on t-shirts and socks. A t-shirt costs $10 and a pair of socks costs $2.50. If T represents the number of t-shirts and P represents the number of pairs of socks that Tyler buys, we should not say I'm sorry. We can represent this situation with the equation 10T plus $2.50 P equals 45. We've got two questions that we're starting off with, and it's questions that are both asking if like a combination of numbers can be a solution. So looking at number 1, we've got, is t equals 3 and p equals 6 a solution to this equation? Now, you might already have an idea of what we should do to help identify if this is a solution or not. I just want to start off by, when we say t equals 3 and p equals 6, what does that mean in this situation? What does that mean in the story? Well, it's asking t equals 3. We know T is the number of t-shirts, so that would be 3 t-shirts. And P equals 6 would be 6 pairs of socks. So when we're asking if 3 t-shirts and 6 pairs of socks is a possible solution, we're asking, is that a combination of things that Tyler could buy? Go ahead, pause the video and see if you can figure out, is that a possible combination of quantities of those 2 items he could buy? The most direct way to confirm this is going to be similar to what we did a moment ago. It's using substitution. We're going to take that $10 we know each shirt costs and multiply it by those 3 shirts he wants to buy. And we're going to take that $2.50 we know each pair of socks cost and multiply that by the 6 pairs of socks. And we're going to check and see, does that actually result in him spending $45? That's what I'm trying to look for. Well, 10 times 3 is 30, and 250 times 6 is going to be 15. And so, looking at that, yep, that is true. 45 equals 45. That lets me know that, yes, this is a solution. 3 t-shirts and 6 pairs of socks would cost $45. In other words, that pair of numbers, the 3 and the 6, is meeting all of the constraints of this problem. Go ahead and try number 2 as well. See if you can figure out, is t equal 4 and p equal 2 a solution to this equation? Number 2, it's going to look real similar to what we did in number 1, except now we're using different values. For number 2, I'm checking to see, could he buy 4 t-shirts and 2 pairs of socks? I'm going to substitute 4 for t, and I'm going to substitute 2 for p, and I'm checking to see, would it equal 45? 10 times 4 is 40, 250 times 2 is 5, and sure enough, I see it is a solution. So I'm going to say something similar to above. Yes, it is a solution because, let me write that. It is a solution because 4 t-shirts and 2 pairs of socks equals $45. In other words, that pair of numbers meets the constraints of the problem. Now, pause for a moment and look at what we just said. We said that this right here is a solution, and we also said this right here is a solution for this equation. So right away, I'm noticing this problem's a little different from what we did earlier. Above, when we were talking about an equation in one variable, we said there was only one possibility. For our problem we were looking at, the only possibility was Juana had to work 8 hours. Not more, not less, just exactly 8 hours. But down here, when we're talking about 2 variables, 2 unknowns, we're seeing there's more than one combination that could work out. He could maybe buy 3 t-shirts and 6 pairs of socks. He could buy 4 t-shirts and 2 pairs of socks. There's going to be more than one solution. There's going to be more than one pair of numbers that, when we substitute, make that equation true. So if I come down to number 3 is asking, can you find another possible solution for this equation? This one's a little trickier. You might have to play around with numbers. Chances are the first pair of numbers you pick isn't going to work out. But go ahead, pause that video, play around a little bit using this equation and the conversation we had about numbers 1 and number 2, and see if you can find another possible solution. Go ahead and try that now. Alrighty. Like I said, it might take some playing around with the numbers. I see, if I'm looking at the ones we've already done, we've done 4 t-shirts, we've done 3 t-shirts. Let me try 2 t-shirts. And the way I'm going to do it is I'm going to put 2 in for t-shirts and see if I can figure out what number P would have to be then. Now, I'm keeping in mind, since we're talking about number of t-shirts and number of socks, it wouldn't make sense if he had to buy like 3.2 pairs of socks. But if I do 2 t-shirts, let's see what happens. I'm getting 2.5p equals 25. And when I divide that by 2.5, I'm going to get p equals 10. So I'm seeing he could buy 2 t-shirts and 10 pairs of socks. That also would meet all of the constraints. There's some other options. I think he could buy 1 t-shirt and 14 pairs of socks is also an option. And if you didn't want him buying any t-shirts, he could buy 0 t-shirts and I believe it's 18 pairs of socks. Let me confirm that real quick for us. Yep, 18 pairs of socks times that $250 for each sock would be $45. So we're getting there's lots and lots of possible solutions for this equation here. So again, to summarize, this equation that we were working with, when I look at it, I see it's an equation in 2 variables because there's 2 unknowns, t and p. Because it's an equation in 2 variables, I'm going to scroll down a little bit and highlight this. Because it's an equation in 2 variables, that means that more than one pair of values for t and p can make that equation true. There's the possibility of having multiple solutions. For example, here are 3 possible solutions. Earlier, we had figured out t equals 3 and p equals 6, and t equals 4 and p equals 2. Those were questions 1 and 2. And here's another example. T could also equal 2 and p could equal 10 based on this math right here. In this situation, one constraint is that the combined cost of shirts and socks must equal $45. Other constraints are the cost they gave us of those 2 items as well. Solutions for this are going to be any pair of numbers for t and p that satisfy this constraint. So that would mean, what about t equals 1 and p equals 10? Would that be a solution to this equation? And just to help us out, let me copy down what the equation is. We had said the equation is 10t plus 250p equals 45. Go ahead and consider the question number 4. Pause the video and see if you can answer number 4. What did you come up with? Well, if I'm doing the same process that I've been doing this whole time, I want to check to see if those are solution by substituting them in. So here's my 1 shirt and 10 socks. And I'm checking to see, will that give us the $45? 10 times 1 is 10. 250 times 10 is 25. And our problem here is 10 plus 25 equals 35, not 45. So what did you say? Did you say that this is a solution? Our answer is going to be no. It's not a solution because how could we fill in that blank? It's not a solution because why? You could say because it would cost $35 and not $45. You could say because it's too little money, right? He's supposed to be spending $45. You could say it's because he needs to buy more socks or a t-shirt to bring it up to $45. But the key idea is this right here. It's because it doesn't satisfy the constraint. It doesn't meet the requirements that we have for this problem. It doesn't satisfy the constraint of the total purchase equaling $45, which is what it's going to say down here. The combination of t equals 1 and p equals 10, or other combinations like t equals 2 and p equals 7 are not solutions because they don't meet the constraint. When these pair of values are substituted into the equation, which is what we did right here, we see that they result in statements that are false. We know 35 does not equal 45. So the key ideas from this lesson, remember the goal was to find solutions and interpret what they mean. A great way you can check to see if something is a solution is substitution. That's been a huge idea throughout this lesson. And to be a solution, we're talking about, does it meet the constraints of the problem? Does it meet the limitations and the information that was given to us in that story? Those were the key ideas for this lesson. I hope you found this video helpful. Come back tomorrow for a summary of tomorrow's lesson. Thanks. Bye.